Let's do some examples of balancing chemical reactions. I'm going to do several of these, so feel free to pause the video and work them out yourself, fast forward to ones that look like what you need help with, whatever you need to do. The first step in balancing chemical reactions is to do what I call an atom inventory. Count and see how much you have of everything. I like to do my inventory underneath the arrow. So I'm going to list the different types of elements, C, H, O, and I'm going to count. On the left, I have 6. On the right, I have 1. In terms of hydrogen, on the left, I have 6. On the right, I have 2. For oxygen, I have 2 over here, and I have 2 plus 1 to give me 3 here. One of the things I tell you in your rules is to save oxygen for last. Really, anytime you have an element in more than one place, like this oxygen here, it needs to be last, because changing other things changes it. So let's just balance our carbon first. If we have 6 on the left and only 1 on the right, we have to make there be 6. We have to make there be 6 on the right. The only way to do that is to put a coefficient of 6 right here. Now always change your inventory. Be aware, I'm not grading this inventory. It is for your use. I'm grading these coefficients. But the inventory helps you know what you're doing and how to get it correct. So we have 6 times 1 gives us 6 carbons. We also have 12 plus 1 is 13 oxygen atoms. Let's fix our hydrogen next. There's 6 on the left and only 2 on the right. So a coefficient of 3 will give us 6 hydrogen, and 3 plus 12 gives us 15 oxygen. Now we have a problem over here because we have O2, we're only going to be able to get even numbers if we're using whole number coefficients. So let me teach you a trick. You can put a half number in. You can put in a half number to kind of hold it place. We know that all of our coefficients have to be whole numbers, but we can use a half number just to get us to the right answer. So what times 2 would give us 15? 7.5. And now we have our equations balanced. We have 6 and 6, 6 and 6, 15 and 15. But there's one more step. In order to get this to be whole number ratios, we have to multiply everything by 2. So there's a understood 1 here. So 2 times 1 is 2. This becomes 15, 6, and 12. And that's our balanced equation. Let's look at number 2. Let's do our inventory. I, lead, and let's look at this. If the polyatomic ion stays the same on both sides, you can just keep it together and count it as one thing. It will make your life easier. So let's count. We have 1 sodium to the left and 2 to the right. We have 1 iodine and 4 iodine. We have 1 and 1. We have 2 sulfates, and we have 1 over here. Don't tell me we have 4, because we have 4 oxygens in every 1 sulfate. So we've got lots of things out of balance here. I always start at the top of the list. So 2 to balance that, and then it changes our iodine. But now we see we really need 4 iodine not 2. So we'll just change this coefficient again. Now that gives us 4 and 4. So we're going to change our sodium over here. 2 times 2 gives us 4 and gives us 2. And if we look, we're balanced. They should work out that easily, most of them. The exception is combustion reactions like number 1. Those are generally going to be a little more tricky. Let's look at number 3. We have nitrogen, hydrogen, and oxygen. We have 1 on the left, 1 on the right, 3, and 2, 2, and 2. So we have 1 here and 1 there. Because oxygen is in more than one place, we know we need to leave it to the end. We have 3 hydrogen on one side and 2 on the other. The lowest common denominator is going to be 6, so we're going to go 6. We put a 2 here. We have 6, but we also have 2 nitrogens. We put a 3 here, and we get 6. But we also have 3, 4 oxygens. We put a 2 here to fix the nitrogen. We get 2, now we get 1, 2, 5. So we see we're in the same place with a half number. In order to get 5 here, we're going to have to do 2.5. And that gives us 5. Everybody's balanced now. So we multiply everything by 2. 4, 5, 4, and 6. Remember that your coefficients have to be not only whole number ratios, but the lowest whole number ratio. So it's a good idea to take a look at them at the end and make sure you can't divide them all by the same thing. Let's look at a few more. Let's look at number 4. We have iron. We have OH over here, but we don't see OH over here. So we have to break it apart. We have 1 and 2. We have 3 here because we did 3 times the 1. And we have 3 plus 1 is 4 on this side. We have 3 over here, and we have 2 over here. So let's start by balancing iron, because it's going to change everything else on the left. It gives us 2. We had 3 times 1 gives us 3, times 2 gives us 6, and 6. Let's fix our hydrogens. We have 3 here. This gives us 6, and then we have 3. 3 oxygens here, plus 3 oxygens here, give us 6 total. If you find yourself going around and around and around and just keep changing numbers and keep changing numbers, you've made a mistake somewhere, almost certainly. So just erase your coefficients in your atom inventory and start fresh. It's usually going to be the easiest way to handle that. Let's do one more. In this last one, we have H, we have NO3, and we can keep that together because it's the same on both sides. It stays together. We have magnesium, we have O, and we have H. Again, sorry. We'll count it up here. So we have 1 plus 2 gives me 3 hydrogens. I have 2 on this side. I have 1 nitrate and 2 nitrates. 1 and 1 magnesium. Now, when we're counting oxygens, we don't count these. because we've already counted them right here. We count the ones that aren't in NO3. So we have 2 and we have 1. Now our hydrogen is in 2 places on the left, so we have to make sure that we save that one for last. So let's fix our nitrate. Now we have 2 hydrogens plus 2 hydrogens gives me 4, and we have 2 nitrates. Let's fix our hydrogens on the right now. Put a 2 here to give me 4, and then we also have 2 oxygen atoms, and everything's balanced. Now I picked some hard ones here, but I also picked some easier ones. Hopefully this has given you some good examples and will help you with your balancing. You only get better at balancing by doing it, so just keep practicing and ask for help if you need it.